Hey there, Mr. Sutton back, bringing you a lesson on the discriminant. What could this be? Well, we're going to use this thing, which we'll identify in just a moment, to figure out the number and the type or nature of the roots of quadratic equations. Why do we care? Because once we know this, we can figure out if an expression is factorable. Might be useful. We're going to start this one by having you write the quadratic formula. See if you can do it from memory. All right, here it is again. Now, the reason we had you write this again, other than just wanting to make your life difficult, is there's a specific part of the quadratic formula that actually tells us quite a bit about the roots of an equation that we're trying to solve. And it's this little part in here, this b squared minus 4ac. This has a special name, and that name is the discriminant, which we will call d for short. Now, this discriminant is just the stuff inside this radical, the b squared minus 4ac. It doesn't include the radical. So for our second warm-up, yep, there's another one. Here's a chart I'm going to have you fill in. In this chart, I have given you 4 different cases for the discriminant. First, negative discriminant. Second, discriminant of 0. And the last 2 cases, we have a positive discriminant, but in one case we have a perfect square, and in the second case, we have a non-perfect square. So based on this, see if you can figure out how many roots a quadratic equation in this situation would have, and whether such a quadratic equation would be factorable. Pause the video and give it a shot. All right, let's see if we can agree on something. Number of roots. If you have a negative discriminant, that means you're going to be taking the square root of a negative number, which means you're not going to get any real roots. If you have a discriminant with a value of 0, that means you're going to be square rooting 0, and the square root of 0 is also 0. If you've got negative b plus or minus 0, you've basically just got negative b over 2a. Once you lose that plus or minus, you only have one solution at that point. It's whatever negative b over 2a is. So that would just be one root. Now, if you have a discriminant that's positive, and it's a perfect square, you've basically got negative b plus or minus some integer here, and you'll have to add and subtract that to negative b and divide it by 2a to get the answers. That'll give you 2 different answers because you've got a plus or minus still in the picture. And that's not going to change if the stuff inside here is not a perfect square. What will change if this is not a perfect square is you won't be able to combine it with the negative b and reduce your answer at all. But you'll still have 2 different roots. They'll just both be irrational roots. Now, the question, which of these situations gives us factorable quadratics? Well, if you don't have any roots, then there's nothing you're going to be able to factor this into in the first place. And by factorable, by the way, we mean you can factor it into x minus or plus some rational number. So no roots, can't do that at all. Now, let's say you only have one root. This will be factorable. It'll be factorable into x minus whatever that one root is. You'll just have that inside a squared parentheses. If we have a perfect square, that means you're going to be able to get 2 rational numbers out of this. That means you're going to be able to just write x minus whatever those 2 rational numbers are. So that would also be factorable. No perfect square, you're not going to have rational numbers, so you will not be able to factor this, at least not using nice integers. So we're going to go ahead now and actually use the discriminant on an actual quadratic equation to figure out how many real roots we have and whether this is factorable. Now this one, you can see just by trying to factor it real quick that it's not working out so well. But let's use the discriminant to prove whether or not we can factor this. So again, we've got b squared minus 4ac. So that's going to be negative 3 squared minus 4 times 1 times negative 1. That'll be 9 plus 4, which is 13. Now 13, that is a positive number, but it's not a perfect square. So greater than 0, not a perfect square. That means that since it's a positive number, we will have 2 real roots. We're going to have basically like 3 plus or minus the square root of 13 all over 2. But because it's an irrational number, the square root of 13, we're not going to be able to actually factor this quadratic to get that kind of answer. So 2 roots, not factorable. So using that kind of reasoning, go ahead and try the next 3 examples on your own. Pause the video and do that. All right, let's see how you did. Second example, we've got negative 10 squared minus 4 times 3 times 11. So that'll be 100. And let's see, this is going to be whatever 12 times 11 is, so 100 minus 132, so negative 32. So we have a discriminant that's less than 0. This means you're going to be trying to square root a negative number, which means you're not going to get any real answers, and therefore it's not going to be factorable. For this next example, they are a little bit sneaky. You may notice this is not in standard quadratic form. Well, discriminant stuff is based on the quadratic formula. So if your original is not in standard quadratic form, it's not going to work for discriminant analysis either. So let's put it in that form. That'll be 81x squared plus 18x plus 1. So this is going to be, if we plug that in, 18 squared minus 4 times 81 times 1. And I'm going to cheat and use the calculator on this one. So plug in all that in. I don't really need to put this times 1 here, but I will anyway. That comes out to 0. So what that means, if your discriminant is 0, that means you have 1 root, because you've got plus or minus the square root of 0, which is just the same number. And then that means it's going to be factorable. If you have 1 root, then you can always factor it. They were also kind of sneaky on this last problem. Although we do have 0 on one side, this is not in order. To get it in standard form, we have to move that 10 past the x there. There we go. So plugging it into our discriminant now, we've got negative 1 squared minus 4 times negative 3 times 10. So that's positive 1 plus 120, so that's 121. 121 is a positive perfect square. So that means that we're going to have 2 roots, and this is going to be factorable. So one final thought before we leave here, and that is, why do we care? Why do we care about the discriminant? Well, it is nice to have a way of figuring out if a quadratic is factorable before we try like 110 different combinations of things and none of them work. So there is that. At the same time, you might be wondering, well, if we're going to solve a quadratic by any method, by the time we've taken all this time to find the discriminant, wouldn't it be faster to just go ahead and actually finish the quadratic formula and call it a day? And the answer is yes. If you've already done this work, moving forward with the quadratic formula is faster than just going back and factoring things. Having said that, there are times when we're going to want to factor for other reasons other than just solving the quadratic. So with that parting thought, this is Mr. Sutton signing off.